Hello, my name is Li, and my E-Talk topic is Impact of Interannual Variation on Rapidly Intensified Super Typhoon Meranti in 2016. Typhoon is one of the severe weather systems in the western North Pacific. The rapidly intensified tropical cyclones are defined as a wind speed increase of 30 knots or more in a 24-hour period, hereafter denoted as RI in this film. Several oceanic and atmospheric variables are also defined to identify the development with or without RI process. In general, sea surface temperature is highlighted as an important index to conclude RI and non-RI tropical cyclone respectively. Besides, most RI processes exist during the first 66 hours after the cyclone formation and could last for 1 or 2 days. Experts also indicated typhoon's track forecast has been improved in past 3 decades, but intensity prediction still remains a challenging task. In past 39 years, 237 typhoon warnings affecting Taiwan were issued. 30 cases occurred in September, which is the period of time during seasonal transition from summer to autumn. Especially in 2016, 3 cases came one after another toward Taiwan in that year's September. They are Typhoon Meranti, Malakas, and Maggie. Now, here comes the question. Can RI be better interpreted in typhoon itself or environmental change? In this study, the JTWC Space Check and NOAA's reanalysis data are used to consider as a ground truth. Then the selecting criteria contains 2 main conditions. First, those cases that satisfied the physics of typhoon formation, and second, typhoon's propagating routes would be further examined to move into the window toward Taiwan. Climatological computations and different timescale bandpass filters are mainly employed in this study for further analysis. Previous research presented that interannual typhoon variability can be effectively modulated by SST and lower-level circulation. On the horizontal charts, the result shows a higher SST of about 0.5 degrees Celsius for typhoon genesis than the climatology. Meanwhile, 850 hectopascal positive velocity potential and negative stream function provide lower-level convergence and low-pressure area for typhoon development, and form maximum and minimum centered close to Taiwan. So the environment in September of 2016 was good for typhoon's genesis and could successfully lead the strength development. While looking into the time series of centered maximum wind speed for the 3 cases after formation and before their landfall, there came obviously the RI process with their propagation. Typhoon Meranti has experienced totally 9 steps in which the entire RI process extended for 3 days. On the contrary, Malakas and Maggie just experienced 1 and 3 steps during their life cycles instead. Besides, all the major RI occurred during D-3 to D-2 before landfall, and 1/3 of Meranti's RI steps were even double the value of 30 knots within 24 hours. Due to the sustaining RI process, it kept strengthening and became highly effective to Meranti's development way faster than the other 2 typhoons in the same month. Here we take Typhoon Meranti and Malakas as strong and weak cases respectively to compare with each other. In the final result, the total value of 6 indices suggests that Meranti enjoyed most of the good conditions in this table. However, 3 to 10 day bandpass filter mainly shows the synoptic scale anomaly that is the same as typhoon's characteristics. On the other hand, 30 to 60 day bandpass filter shows the lower vertical wind shear and higher sea surface temperature would represent the large-scale environmental change to really steer typhoon's development. Lastly, future work will be focused on test other oceanic parameters. Also, these above results can be extended to examine RI occurrence frequency in different seasons. This is the end of my E-Talk. Thank you for your watching.